Now I'd like to demonstrate one way to construct a sine wave. What we're going to do is we're going to construct something that looks like sine of omega t. So we have our function of time here, and we have our frequency. Now this little animation is going to show us a way to construct a sine wave. So what I have here, this green line is a rotating vector. And let's just say that the radius of this circle is 1. So here's a vector just rotating slowly around and around. And in the dotted line here, in that yellow dot going up and down, that's the projection. That's the projection of the tip of the green arrow onto the y-axis. And as the vector goes around and around, you can see that the projection on the y-axis is bobbing up and down and up and down. And that's actually going up and down in a sine wave pattern. So now I'm going to switch to a new animation, and we'll see what that dot looks like as it goes up and down in time. So here's the plot. Here's what a sine wave looks like. As you notice, when the green line goes through 0 right there, let's wait till it comes around again, the value of the yellow line when it goes through 0 is 0. So this yellow line here is a plot of sine of omega t. Now, if I go to a projection, this projection was onto the y-axis, and I can do the same animation, but this time project onto the x-axis, and that'll produce for us a cosine wave. Let's see what that looks like. Now, in this case, if we switched over, you can see that the projection, that dotted green line, is onto the x-axis. And what this is doing is it's producing a cosine wave for us. So this is going to be cosine of omega t. Now, because we're tracking the progress on the x-axis, the cosine wave seems to emerge going down on the page. So the time axis is down here. When the green arrow is 0 right there, the value of the cosine was 1. And when it's minus 180 degrees, it's minus 1 on the cosine. So that's why this is a cosine wave. And it has the same frequency as the sine wave we generated. And now I want to show you these two together because it's just sort of a beautiful drawing. I'll leave our animation here for a second. We see our sine wave being generated in yellow, and in orange we see the cosine wave being generated, and they're both coming from this rotating green vector. So this is a really simple demonstration of a way to generate sines and cosines with this rotating vector idea. We're going to be able to generate this rotating vector using some ideas from complex arithmetic and Euler's formula. I find these to be a really beautiful pattern, and it emerges from such a simple idea as a rotating vector.